Hi everyone and welcome to Tumamina Teaching. This is not your typical Tumamina Teaching video lesson as you might be familiar with. This is an exam preparation lesson. So the idea is in the description of the video there's an exam and you can complete this online or you can print it as you please, and then there'll be a teacher who runs through the exam with you question by question. And it's a great preparation tool for the exam or revision as you please, and I hope that you will benefit from this greatly. Enjoy!
Okay, let's start with section A and first question 1. So section A is on geometry of 2D shapes and straight line geometry. It's 19 marks. Then we start with the figure over there, and then the first question is what type of triangle is shown in figure 1? And then because we can see that all three sides are equal, we can immediately say that it's an equilateral triangle. So I'll just write it in there that it's definitely an equilateral triangle. I'm just going to do this. It's an equilateral triangle since all the sides are equal. Okay, next question. How large are the angles in figure 1? Now what you should know for an equilateral triangle, and you can also actually solve this using interior angles of a triangle, is each angle needs to be 60 degrees. Each angle needs to be 60 degrees, so then we can just write 60. And then now we have figure 2, figure ABCD, and then question 3. Question 3 then states, give only the numeric value in degrees of angle A plus angle B plus angle C plus angle D. But we don't know what ABCD is, but it's okay, because what you should know from theory is that the sum of the interior angles of any quadrilateral is always 360 degrees. So the sum of the interior angles of a quadrilateral, some of the interior angles of a quadrilateral so we know that the sum of the interior angles of a quadrilateral is always equal to 360 degrees, and therefore we know that the answer here is just 360. Next question. Okay, so the next question then is, if AB is parallel to CD, what shape is figure 2? Okay, if AB is parallel to CD, then it's clear that figure 2 needs to be a trapezium, because only one pair of parallel sides, we know it needs to be a trapezium. So it's a trapezium. So it's a trapezium since one pair of parallel sides, since one pair of parallel sides. I'm just writing shorthand over here. Okay, next question. For figure 2, if AB is parallel to CD and B is 100 degrees, what is the size of C? So if B is 100, what is C if AB and CD are parallel? Now if B is 100, you can immediately say that C is 80. C is immediately 80 degrees Celsius because the sum of the co-interior angles of a shape is always equal to 180 degrees, but then it's important that these two lines are parallel, which is the case. So we know that if B is 100, C should be 80. Okay? And like I said, now the next question is, what is your reason? So the reason is co-interior angles. So co-interior angles. The reason is co-interior angles, and it's important that AB is parallel to CD. Co-interior angles, and it's important that AB is parallel to CD. Okay, so our reason is co-interior angles. Next question. again for figure, so the next question is again for figure 2. If AB is parallel to CD, like we already said because it's a trapezium, and B is 100 degrees, what is the size of A? Right, so now we know that B is 100 and AB is parallel to CD. What is A? It looks like A is 90 degrees, but in fact we don't actually have enough information to calculate A. Remember that you can't guess answers or go off of it looks like. Since I don't give any information about AD or anything other, or angle D or anything other about the shape, I only know that AB is parallel to CD. I don't actually have enough information to calculate angle A. So the correct answer is not enough information. So not enough info. It's not enough info because we would actually need question. If the corresponding angles of two figures are equal, then these two figures are. If the corresponding angles of two figures are equal, then these two figures are similar. Okay, so what you need to know that it's similar. So you need to know that any two shapes where all their corresponding angles are equal, these two shapes will always be similar, which means the ratio of the sides are the same. Okay, so next we have question 9. We get a rectangle A has side lengths of 4 and 6 that you can see, and rectangle B has its shorter side of length 10, as indicated in the figure. If rectangle A is similar to rectangle B, what is the perimeter of rectangle B? Okay, so what you now immediately need to know is that if two shapes are similar, the ratio of their sides are the same. Okay, that means that B is just a magnification of A. Exact magnification, not a stretch or a compression. So the short side of A, 4, changed to 10. The ratio of the sides are the same. That means that the 10 over the 4 is equal to the missing side, let's just call that x, is equal to the missing side over 6. So that means how 4 changed to 10 is the same as how x will change from 6. And now we can just solve x by saying that x is equal to 10 over 4 times 6, which would then be equal to 15. Let's see if they gave us a unit. No. So then the missing side of B, the longer side, is then 15 units. The longer side is then 15 units. But that's not what they asked. They didn't ask us for the longer side, they asked us for the perimeter. Now the perimeter of B, so now we have all the sides because it's a rectangle, and then the perimeter of B, let's just write it like that. The perimeter of B will then be equal to 2 times 10 plus 15, because that is the two side length, and that's just 2 times 25, and that would be equal to 50 units. So the perimeter of B is then equal to 50 units. Okay, next we have question 10. A rectangle is a special kind of, mark all the correct options. A rectangle is a special kind of. So now we have a rectangle, okay? Now you need to think of all the characteristics of a rectangle. Now you need to think of all the characteristics of a rectangle that you know. Angles are 90 degrees, the opposite sides are equal, the diagonals, the opposite sides are equal. There's stuff you know about the diagonals too, the opposite sides are parallel, okay? Now, okay, so a rectangle, which I drew over here, there's certain characteristics of it. And just to think of what a rectangle is, a special type of what, you need to think of another shape that if you add information, not subtract, if you add information, you'll get a rectangle. So it's not a square, because a square has more information than a rectangle. A parallelogram is correct, Because if you take a parallelogram and you just make all the interior angles 90 degrees, or geometrically you just bump it straight, you'll actually get a parallelogram. Trapezium is the same, because the minimum characteristic of a trapezium is one pair of parallel sides or one pair of opposite sides are parallel, and that is the case for a rectangle as well. And so a rectangle is also a special kind of trapezium. And another way to think about it is a rectangle a trapezium? Yes, because one pair of opposite sides is parallel. So therefore trapezium is a correct answer. Is a rectangle a parallelogram? Yes, it is. It's just a special one because two pairs of opposite sides are indeed equal. Is a rectangle a square? No, it's not. Is a rectangle a rhombus? No, it's not, because a rhombus needs to have all four sides are equal in length, and that's not the case for a rectangle. So what you basically just need to ask yourself is a rectangle a parallelogram? Yes, it is. Is it a trapezium? Yes, it is. So the correct answer is parallelogram and trapezium, because a rectangle are both those things. So you can just write here that a rectangle is a parallelogram and a trapezium. A parallelogram and a trapezium, not any of the others. Okay, next question. Mark all the properties that are true for a kite. So I'm just going to draw a kite to refresh your memory. A kite is a shape that looks like a kite. An important characteristics of a kite is that the two pairs of the adjacent sides are equal. That's an important characteristics. And then something that you learned maybe for the first time in grade 9 is that it's also true that the diagonals bisect each other and that the diagonals are perpendicular. Okay, so the diagonals bisect each other. Kite does not necessarily contain a right angle. The diagonals are perpendicular. The opposite sides are definitely not parallel, but two pairs of adjacent sides are indeed equal. Next question. Why is triangle X congruent to triangle Y? Now, to answer this question, you need to know the 4 reasons for congruency, the 4 possible reasons for congruency in triangles. There are 4 of them. Okay. And you'll see here that all 4 are listed as an option with the extra that they are not necessarily congruent. It's always important to check this. So you can see clearly from the pictures that you have 2 sides, 2 corresponding sides that are equal and an included angle that is equal. Therefore you can say that it's this option over here, 2 corresponding sides and the included angle are equal. It's important that this angle needs to be included, and that is indeed the case. And then how they sometimes abbreviate it as a reason, your reason would then be side, angle, side. So that would be your reason, side, angle, side, and it's important that the interior angle is included between the 2 sides, as we'll see in a few questions later. Okay, next question. Consider the following figure. What is X? Now there's more than one way of calculating this answer, but I'm going to go with the triangle that has the most information. So normally in a test at school, if you needed to write this out, we'll give you labels on the angles so that you can write it out clearly. However, there isn't labels because on a Google form test you only need to give the answer. But we want to calculate X, and the only thing we can actually use is the sum of the interior angles of a triangle. But we only have 2 of these angles, so we want the third one. But luckily, because these 2 sides are parallel, we know that this side over here needs to be 2x, and that's according to alternating angles, because we know that alternating angles are equal if the correct 2 pairs of sides are, or the correct pair of sides are parallel. So we know that this angle is equal to 2x as well, and therefore from the sum of the interior angles of a triangle, Therefore, from the sum of the interior angles of a triangle, we have that x plus 2x plus the other angle is 30 degrees plus 30 degrees must be equal to 180 degrees, and your reason is the sum of the interior angles of a triangle. And now you can just use algebra to simplify. So you have 3x is equal to 150 degrees, and then you have that x is equal to 50 degrees. So we know that x is equal to 50 degrees. Next question. In class, a teacher tells Jack and Cyril to draw the following triangle. One side has length 10. I'm just going to try and draw that over here. One side has length 10 with an angle of 45 degrees next to it. Let's just do that. Say that's a 45-degree angle. We don't know how long the side is yet. Furthermore, the side of length 8 is opposite to the 45-degree angle. So we don't know how long that is, and then somewhere over here, then we have another side which is opposite to the 45-degree angle, which is 8 units long. And then they say, in the end, Jack and Cyril draw two different triangles. What happened? So the information we have, I drew over here. We have a triangle with a 45-degree angle, and opposite to it a side of length 10, and then adjacent to it a side of length 10, and then opposite to the 45-degree angle, we have a side of length 8. Okay. Now, let's say this was Jack's drawing. Okay, let's say this was Jack. Let's say this was Jack. And say Cyril draw another triangle. Okay, let's say that is the 8. And then we have some triangle over here with a side of 10 and 45 degrees over here. So now, how you need to solve this is basically, let's say Jack and Cyril drew a triangle. Now, first question you ask yourself is, do they have enough information to draw a triangle? And the answer is yes, because as long as what I drew made sense, and even if you take a ruler, that you can draw a triangle like this. Okay, but so the first question you ask yourself is it possible that for Jack and Cyril to draw a triangle, in fact? And it should be clear that the answer is yes. Now, if such a triangle exists, is a clever way of asking it is, does this uniquely define it? It's quite a clever way of saying it. And what it just means is, did Jack and Cyril draw the same triangle, or is one of them wrong? And the answer is, in fact, that both can be right, because two triangles can be drawn with the given information. And the reason for that is what I said earlier, that let's say we have two different triangles. Okay, let's say we have two triangles with sides 10, 8, and 45 degrees, as I indicated here. Another way of phrasing the question is, are Jack and Cyril's triangles congruent? And your answer should be not necessarily, because we have two sides and an angle, and the only reason you have for congruency of two sides and an angle is side, angle, side, where the angle is included between the two sides. This is not the case, and therefore they could have drawn different triangles. And you'll actually see that once you answer the question, a link will pop up where an example is given where you can play around with values, where you can actually get exactly two triangles with that information. You can draw two triangles with that information. Okay. And then the last question would be question 15. A full rotation consists of 360 degrees. Okay, this you know, right? You know that, say this is a point, a full rotation around a point is 360 degrees. Have you ever wondered why? And then the answer is that it's merely a convention we employ. We said that, okay, let's say a circle has 360 degrees. But what if we said it was 100 degrees? How many degrees would a right angle be? Now, all you need to know is that a right angle is 90 degrees, which is just a quarter of 360 degrees, okay? Because if you even add it here, a right angle is always a quarter of a full rotation. So therefore, if we had 100 degree as a full rotation, 100 degrees, then a right angle would actually be 25 degrees. Then a right angle would be 25 degrees. And that is the end of section A. Thanks for listening. Okay, let's start with section B, which is the theorem of Pythagoras. So, consider the following figure. Okay, let's start with section B, the theorem of Pythagoras. First, they give us an interesting fact about Pythagoras. And then, the first question is, consider the following figure. What is the length of the hypotenuse? So first you need to know that the hypotenuse is this longest side over here. And you have a length of 8 and 6, and then you should just use the theorem of Pythagoras that you know. Let's say the hypotenuse is h, that h squared is equal to 8 squared plus 6 squared. That's just the theorem of Pythagoras. And then we have that h is equal to the square root of 8 squared plus 6 squared. So h is then equal to the square root of 8 squared plus 6 squared, which is equal to 100. Therefore, h is equal to 10 meters. Okay, the hypotenuse is equal to 10 meters. Okay, next question. A Pythagorean triple is a set of 3 natural numbers that can be the sides of a right triangle. As an example, 3, 4, 5 is 1 by the equation below, because 5 squared is equal to 3 squared plus 4 squared. Mark all the Pythagorean triples. So what you should obviously notice is that the hypotenuse is always the longest side. Okay, and there is only one way to check all 5 of these options, and that is to see if the Pythagorean relationship holds. So now we have 7, 24, and 30. So then what you compare is 7 squared plus 24 squared versus 30 squared. Okay, and you can just type that into your calculator. 7 squared plus 24 squared, so 7, that's 625 versus 30 squared. 30 squared is actually 900. Therefore, this is not a correct option. Next one is 10, 20, 40. Okay, so then again we say 10 squared plus 20 squared, 20 squared versus 40 squared. Remember that the longest side is always on its own, and that's 10 squared plus 20 squared. On your calculator, 10 squared plus 20 squared is 500 versus 40 squared is 1600. That's not a correct option either. The next option is 28, 45, 53. 28 squared plus 45 squared versus 53 squared. Type that into your calculator and you'll find that. If you type that into your calculator, you'll find that both are equal to 2809. Therefore, this is a correct option. They asked us to mark all the options, so it's not a multiple choice question, it's a checkbox problem. So then you can just do the same with the other two. You type 36, 77, and 85 into your calculator, or the squares of them. So you type 36 squared plus 77 squared into your calculator, and then you see if it's equal to 85 squared. It is, so that's a correct option. And then you type 10 squared plus 11 squared into your calculator, and then you see if that's the same as 12 squared. It's not, so the only two options are those options over there. Okay, next we have a nice application of Pythagoras. So in this elementary drawing over here, we see that we have a tree, and then a 13-meter rope is tied from the top of the tree, so someone climbed into it, straight to the bottom in a straight line so that the rope isn't slack. And then you see that, okay, I know the rope is 13 meters long, and I can measure easily that the rope ends 5 meters from the base of the tree. How tall is the tree actually? Because it's difficult to measure the height of a tree without a bit of a it's difficult to measure the height of the tree. So now thinking, can I calculate how tall the tree is? And yes, we can. Because the tree is straight, we know it's perpendicular, therefore perpendicular with the ground, therefore we can use Pythagoras. And that the length of the tree, so let's just call that t, the length of the tree is then just the square root of 13 squared minus 5 squared. You type that into your calculator and you'll see that it's 12. And you'll see that it's 12 meters long. So the answer over here is 12. Okay, the next and last question of this section is calculate x, like short and simple. Now we have a triangle with a right angle in it, so we immediately know Pythagoras. Then they give us a hint, x is not 0. Okay, obviously that makes sense, otherwise this triangle wouldn't exist. So how do you calculate x? Well, by using Pythagoras. We know that the two shorter sides, the two shorter sides squared is equal to the long side squared. Okay, so we know that x squared plus the whole of the shorter side squared, x over 2 minus 1 squared, must be equal to the longer side squared, x plus 1. Everything squared. And now you just do algebra. So we know that x squared stays the same. And now you need to say that x over 2 minus 1, everything squared. So that is this term over here squared. So it's x squared over 4. And then you say then that x over 2 times minus 1. And then there is going to be 2 of those. You can write it out first if you want, but I'm just going to do it in one step. So there'll be 2 of those of the x over 2 times 1, and then minus 1 squared is just plus 1. Everything is equal to x squared plus 2x plus 1. Okay, so again I did the same here. It's x squared, and then there's a x times 1, but there'll be 2 of those, and then 1 squared is just 1. You can write out the extra step in there if you want to, but check your answers to make sure it's the same as mine. And now we just simplify. Okay, so now you can see that we have an x squared on the left hand side and an x squared on the right hand side. We can cancel them out, and then we are left with x squared over 4. We have minus 2 times x, which is just minus x, and then this plus 2x I'm going to take over, it becomes minus 2x, and then we have then we also have a plus 1 and another plus 1, which will definitely cancel out, and then I'll set everything equal to 0. Okay, so now we have x squared over 4 minus 3x is equal to 0. And something like this should scream factorization, because you have an equal 0 and you have an x in each term. So it's a common factor of x, leaving you with x over 4 minus 3 is equal to 0. And I'm just going to continue on the right hand side. And now we know that x is equal to 0, or x over 4 minus 3 is equal to 0. We already know that x can't be 0 because they asked us don't make x 0. And then if I just continue over here, we have that x over 4 is equal to 3, and therefore x is equal to 12. X is equal to 12. A very nice solution to a problem that might have not seemed so easy at the start. And that is the end of the second section. Thanks. Okay, let's start with section C, area and perimeter of 2D shapes. It's 9 marks. So the first question is, what is the area of a parallelogram? So this is simple theory that you should know. So let's just write it in the notes. So the area, say, of a parallelogram, just going to write like two parallel lines in the M, is equal to, en ons kan net opsoek, area of parallelogram. Base times height. Ha! Okay, so this is just a formula that you should know, and it's just the base times the height. So it's the base times the height, and that's this option over here. Okay, next question. Question 2. Calculate the area of the following shape if D is equal to 100 centimeters. Give only the numeric value in square centimeters. Use a full stop if decimals are present. Okay, so we have a circle with diameter D. It's important that D is the diameter. And they ask for the area. Now, the formula we have for the area of a circle, let's just say A of a circle, is pi times the radius squared. Okay, and that is equal to pi times, now if D is equal to 100 centimeters, D is the diameter, then the radius is equal to 50 centimeters. So then the radius is equal to 50 centimeters squared, and then you just type that into your calculator and you'll get the area as, then you'll get the area as 7853 to 2 decimal places, comma 98 square centimeters. 7853,98 square centimeters. Okay, so they tell us to only give the numeric value, so leave the centimeters out, and a full stop for the decimal, so it'll be 7853.98. 7853.98. And question number 3 states, a farm has an area of 20,000 square meters. What is its area in square kilometers? Okay, so they tell us the area of the farm is 20,000 square meters. What is this in square kilometers? What is this in square kilometers or kilometers? And what you should know is that meters to kilometer is, meter to kilometer is divided by 1,000, but because it's meter to the power of 2, it should be 1,000 to the power of 2 as well. Just type that into your calculator. 20,000 divided by 1,000 to the power of 2, and you get an answer of, then you get an answer of 0,02 square kilometers. 0,02 square kilometers, and then remember to use a full stop for the decimal separator. Next question would be question number 4. That states, say the following figure has an area of 10 square units. If both A and B are doubled, what is the new figure's area? Okay, if both A and B are doubled, what is the new figure's area? Alright, so we know that its current area is equal to 10 square units. Right, so it's equal to 10. Then if both the length and the breadth, both the length and the breadth is doubled, what is the new area? So what you need to know now is that the area is equal to the length times the breadth. Okay, so you can try and figure this out as well. I'll just show you the algebraic way to do it. So we know that the area is length times breadth because it's a rectangle, length times breadth, because it's a rectangle. And then let's say, okay, and in this case, L times B is A times B, because that's the variables they're using over here. And now they say, what if it changed? Now they're saying, what if the A and the B changed to double, right? So A changes to 2A and B changes to 2B, right? But 2A times 2B is just 4AB, or 4 times A times B. But A times B is actually just the original area, which is equal to 10. And now all of a sudden we know that the new area should be 4 times 10, which is 40 square units. So the answer over here is 40. Okay, next question, question number 5. For which positive side length is the perimeter and the area of a square equal? You are again welcome to guess the answer if you want to, but I'll show you the algebraic way of solving it. So they ask us for which positive side length is the perimeter and area of a square equal. So this is actually quite easy if you think about it. So what is the perimeter of a square? So the perimeter of a square, let's say P, is equal to 4 times S, where S is the side length, right? And the area of a square is equal to S squared. Now, if the perimeter and area are equal, then we know that 4S should be equal to S squared. Now, this question is basically begging you to be able to use factorization. So then what you do is you say S squared minus 4S is equal to 0. So from grade 9 on, as soon as you see an equation with a square and as soon as you see an equation, let's say x squared and then another x, or y squared and another y, you should immediately know, put everything on the one side of the equation, so you get 0 on the other side, and then factorize. So 4s minus s squared minus 4s is equal to 0. Definitely a common factor of s, which leaves us with s minus 4 is equal to 0. So this implies that either s is equal to 0 or s is equal to 4, and since they asked for a positive value, we know that s is equal to 4 is the answer. So a side length of 4 is the only time that the perimeter and the area of a square will be equal. Okay, so the next question is the last question. Question 6 says, the following figure is a rhombus. Its area can be calculated in the following way. A is equal to AC times BD divided by X. In other words, the product of the length of the diagonals divided by X. What is X? Okay, so now, before you freak out, just calm down and think about what you know. Okay, it's a rhombus, so you know all the sides are of equal length. You also know that the diagonals, so what they're telling us is that the area of this rhombus can be calculated by AC, which is the length of the one diagonal, times BD, which is the length of the other diagonal, everything divided by X. But then they ask us, what is X? Okay, the question is, what is X? So, let's see what we have. So, how would you calculate this area? Well, one way you can do it is what I immediately see is it looks like a triangle over here, okay? So then what you do is you say, okay, the area of that triangle there, triangle ABC, so the area of triangle ABC is equal to a half times its base, and let's use AC as the base, times AC times BF. Okay, but now a property of a rhombus that you should know is that the diagonals bisect one another. Therefore, BF is half of BD. So we have half times AC times BF is half of BD. And then if we simplify this, we get AC times BD over 4. Okay, that's the area of triangle ABC. The area of triangle ABC. But that's only half of the area of a rhombus. We still need the area of triangle ACD. You can calculate it, you'll get the same result, because AC is still the base of the triangle, and the height of the triangle DF is again just half of BD. So you actually get this again. So that means that the area of the whole rhombus is equal to AC times BD, everything over 4, times by 2, and now you have AC over BD BD everything over 2, and that's actually a formula that you'll find commonly on Google if you search for the area. So now we say that the answer is 2 since they asked us what is x. And that is the end of the section. Thank you. Alright, let's start with section D, which is surface area and volume. Okay, so the first question is, which option is a correct unit for surface area? So we have centimeters, centimeter squared, centimeter to the power of 3, centimeter to the power of 4, and then other. And for surface area, the correct unit is definitely centimeters squared. Okay, because surface area is just the total area, so the unit will always be centimeter squared or meter squared or whatever, but always the square option. Next question. What is an appropriate definition of volume? Okay, we have the amount of space that the 2D object takes up. No, volume is always 3D. The amount of space that a 3D object takes up. That sounds right. How long it will take to walk around an object? No, but that is actually a sort of a definition of circumference or perimeter. That's sort of a definition of circumference or perimeter. The total area on the outside of a 3D area? No, that is actually your surface area. And how heavy an object is, obviously not. Yeah, so we know that the volume can basically be defined as the amount of space a 3D object takes up. Okay, next question. A cube has sides of length 40 millimeters. What is its volume? So to answer this question, you need to know that the volume of a cube is given by the side length to the power of 3. And since it's 40 millimeters, it's just 40 to the power of 3, which is equal to 64000. So it's 64,000 cubic millimeters. And then they ask for only the numeric values, and then we write 64000. Okay, so the answer is 64 cubic millimeters, but they actually ask us to give the answer in cubic centimeters. So now to get from millimeter to centimeter, we want our answer in cubic centimeters. To get from millimeters to centimeters, we divide by 10. But because it's to the power of 3, we divide by 10 to the power of 3, which will give us an answer of 64 cubic centimeters. In the next question, the following bottle can hold 500 milliliters of water. What is its volume in cubic centimeters? So to answer this question, you need to know that 1 liter is equal to 1,000 cubic centimeters. Okay, so if 1 liter is equal to 1,000 cubic centimeters, then we know that the 500 milliliter, which is contained in this bottle, so we know that 500 milliliters is equal to half a liter or 0.5 liters, and that is then therefore equal to 500 cubic centimeters. Next question. Consider the following prism. If it has a volume of 10 cubic meters, so we know that its volume is currently 10 cubic meters, then if its height is doubled, what is the new volume? Okay, so it tells us that it's some prism. So what you need to know about a prism is that the volume of a prism is, the volume of a prism is equal to the area of the base. The area of the base times its height. Okay, therefore, if this is changed to the area of the base times, and they say that the height is doubled, so it changes to area of the base times 2h, but that's just equal to 2 times the area of the base times h, but we know that the area of the base times h is just equal to 10. Therefore, the new volume is 20 cubic meters, or in other words, if the base stays the same and the height is doubled, the volume is also doubled. So they ask for only the numeric value, so we know the answer is 20. Okay, next question. Consider the following prism, where L is equal to 20 meters, B is equal to 8 meters, and H is equal to 3 meters. You can assume that H bisects B and that the triangle is an isosceles triangle. What is the total surface area of the prism? Okay, so this prism over here, the total surface area is obviously the areas on the outside, all of them. So if you count the faces, you see that there are 3 rectangles and 2 triangles. Okay, so make sure you see that there are 3 rectangles and 2 triangles, and now we just add these areas. Okay, so let's start with the top face. We can see over here of the rectangle. Area of the rectangle is just length times its breadth. So to calculate the surface area of this prism, we need the areas of the different faces, and I already said that there are 5 different faces, the 3 rectangles and the 2 triangles. Okay, so let's look at this top face over here, this rectangle. Now we already have its length L, but what about its breadth, which would be one of the sides of the isosceles triangle? Okay, now they haven't given it to us, but don't panic, because we know that H is perpendicular on B, it bisects B, and you should actually now need to use Pythagoras. Okay, so this missing side over here, I'm just going to call it S. So we know that this missing side over here, S, is equal to the square root by Pythagoras of h squared plus, now b over here, we have b over here, but it's not the whole of b. We actually know that h bisects b, and b is equal to 8, but just first going to write it like this. So it bisects b, so which means we have b over 2 squared, and then everything, the square root of everything. And now they gave us h as 3, so we have 3 squared plus, and then b over 2 is 4, because b is just 8, so then we have 4 squared. And then if you calculate this, you'll find that S is just equal to 5 meters. And then we have that the area of rectangle 1 so now we know that the area of rectangle 1 is equal to its length, which is just L, which we know is 20, times its breadth, which in this case is the side S I calculated, so that is 5. So then we know that the area of rectangle 1 is equal to 100 square meters. We know that it's equal to 100 square meters. Okay, and then if you look at the second rectangle, and it also has the breadth, which is the one side of the isosceles triangle. Because it's an isosceles triangle, we know it's exactly the same measurement, so this is just actually a duplicate of the other rectangle. So we know that the area of rectangle 2 is also equal to 100 square meters. Now we're just left with the area of rectangle 3, then we're done with the rectangles. Now this is the bottom rectangle in this picture on the left. Its length is still L. But this time its breadth is equal to B. So the length is still L, which is 20, but its breadth is equal to B, which is 8. And now we get 160 square meters. Okay, so that shows us that the rectangle at the bottom is actually larger than the rectangles at the top. And then we're left with the 2 triangles, which are identical. So I'm just going to say that the area of the triangles together is equal to 2 times, because there's 2 of them, area of a triangle is half times its base, which is B, which we know is 8, times its height, which is h, and we're given that h is equal to 3. And then if you multiply all that together, you get 24 square meters. And that implies that the total surface area, of this prism, then we know that the total surface area is just the sum of all the areas, so it's the 24 plus 2 times the 100 plus the 160, and that leaves us with 384 square meters. So the next question, being the last question, which is the last question, is: the following cylinder can hold 4 liters of water. If its radius is halved, how much water can it hold now? Okay, if the radius is halved, how much water can it hold now? Okay, so to answer this question, we need to know that the volume of a sphere is equal to the area of the base, which is pi r squared, times the height. Okay. We also know that the volume is equal to 4 liters, which is the same as 4,000 cubic centimeters. So we know that our volume is equal to 4,000 cubic centimeters. Okay. Now again, like in the previous sums, let's say this is changed such that the radius is halved. Now we have pi times r over 2 squared times h, which is just equal to pi r squared over 4 times h, and this is equal to a quarter times pi r squared h, which we know is pi r squared h, we actually know is equal to 4,000, and therefore we now have our answer of 1,000 cubic centimeters, which is just equal to 1 liter. And that's the end of this section. Right, next we do transformation geometry for 10 marks. It starts here just with the picture of René Descartes and then an interesting fact about him. And then the first question. Okay, the first question states, point AB is translated 2 units to the left. What are the new coordinates of the point? So if point AB is translated 2 units to the left, then we know that its x coordinate moves 2 places to the left and its y coordinate stays the same. So it's a minus 2b, which is the first option over here. Okay, next we have figure 3. Next we have figure 3 with a yellow point A, and then the question is, first question is, what is the coordinate of A? Okay, so A is over here. So first you do the x coordinate. X is always first, so the x coordinate is minus 3 and the y coordinate is 2. So the point A is then, the coordinates are minus 3, 2. Minus 3, 2. Next question. Okay, so the next question is, translate point A 3 units down to form A accent. What are the coordinates of A accent? Okay, so you can do this visually or algebraically, but we need to move it 3 units down. So if it moves 3 units down, we know the x coordinate will stay the same, and the y coordinate is minus, it's 2 minus 3, so it's minus 1. So the new coordinate is minus 3 minus 1. Minus 3 minus 1. Okay, next question. Reflect point A around the x-axis to form a double accent. What is the coordinate of a double accent? Okay, so now you need to remember that we are reflecting A and not A accent. So we're reflecting this point over the x-axis, and then you can again either figure it out geometrically or algebraically. So our algebraic theory tells us if you reflect it around the x-axis, then the y-coordinate just gets a negative in front. So the x-coordinate stays the same, and the y-coordinate turns into minus 2. So our answer is minus 3 minus 2. Okay, then we're given another figure. What transformation did A undergo to get to point B. What transformation did A undergo to get to point B? Okay, and so they gave us a few options. All of them are reflections, so we know that that's going to be one of our options. And visually and algebraically, the only option is if there's a line over here that looks like that. So the only option is if we reflect it over the line, y is equal to x. We reflect it over the line, y is equal to x. So we reflect it over the line, y is equal to x. And that's because you'll see that the algebra also checks out in that. The algebra also checks out because the coordinates just switch. Okay, next question, question 6. Point x is reflected over the y-axis to form a x-accent. If x-accent is at minus 4, 0, what were the coordinates of x? So x goes to x-accent, which is equal to minus 4, 0. We also know that this was a reflection over the y-axis, right? So reflection over the y-axis means that xy, you can do this geometrically as well, I'm doing it algebraically, xy turns into minus xy. So x-accent, big x-accent is minus 4, 0, and this is equal to minus xy. So the original x is just at 4, 0, because if you reflect 4, 0 over the y-axis, you'll get minus 4, 0. So the answer is 4, 0. Okay, next question. Triangle ABC is a scalene triangle. Okay, so they tell us the triangle ABC is a scalene triangle on the Cartesian plane and has a perimeter of 3 units. If triangle ABC is reflected over the y-axis, what is its perimeter now? And I can immediately say that the perimeter is still 3 units because, and this is something you need to know, that reflections, rotations, etc. does not change the properties of the shape. It's congruent to one another. So we know that the perimeter is still equal to 3 because reflections and rotations and translations do not change the properties of the shape. Okay, next question. Figure 4 contains shape PQRS. Note that all the coordinates are whole numbers, so that just means that if you can read the coordinates off as minus 1, 1, 4, 1, 4, minus 6, and minus 1, minus 6. And then the first question is, consider figure 4, what is its area? Okay, so what is its area? Now, since it's a rectangle, it's just length times breadth. So that would be 1, 2, 3, 4, 5 blocks, or 5 units times 1, 2, 3, 4, 5, 6, 7. So it's just 5 blocks times 7 blocks, or 5 units times 7 units. And that is equal to 35 units squared. 35 units squared. Next question. Consider figure 4. If lines PQ and RS are halved in length, what is the new area of PQRS? So PQ and RS is the shorter two lengths over here. If they are halved, meaning it's still a rectangle, what is the new area? So if these two are halved, you can either count the new squares or you can just think about what it means if the one dimension is halved. So I'm just going to think of it algebraically. You could count it as well, but algebraically we know the area of a rectangle is length times breadth, and therefore if B is turned into half B, then it means that A goes to A over 2, or a half A. So that means the new area it means the new area is just 35 over 2, which is equal to 17,5. Okay, so the answer is 17.5. Just note that you need to use a full stop for the decimal separator. That is what Google Forms prefers. Last question. Parallelogram G is reflected over the line y is equal to x to form a new shape. Which of the following statements are true? Mark all the correct options. Okay. The distance from G's corners to any point to any other point stayed the same. The last question, question 10, says a parallelogram G is reflected over the line y is equal to x to form a new shape. Which of the following statements are true? Okay, first one, the distances from G's corners to any other point on the Cartesian plane stayed the same. That's definitely not true since the coordinates of the corners of G changed. Okay, next one, the old shape is congruent to the new shape. That is definitely always true. Next one, the area of G stayed the same, also always true. The coordinate of G's corners stayed the same, definitely not true because they were reflected. The distances from G's corners to the origin stayed the same. This is true, and this is specifically a property of reflecting it over the line y is equal to x, or the x-axis or the y-axis. If you think about it, you'll see the distances from the origin stay the same. Okay, then these are the 3 points, and then that is the end of this section. Thank you very much. Okay, next we have section F, data handling, for 9 marks. First, there's an inspirational quote about statistics. Then, first question, which of the following research ideas has the least potential for bias? A mathematician looking into weather patterns in South Africa, a fast food supplier looking into health implications of fast food, or the owner of a car dealership doing research on car safety. Now, the last two have a lot of potential for bias because a fast food supplier looking into the health implications of fast food isn't exactly objective because he obviously maybe wants fast food to be more healthy. And then the owner of a car dealership doing research on car safety is also not necessarily objective because it's something he's working with, where a mathematician looking into weather patterns in South Africa has the least potential for bias because a mathematician doesn't necessarily care about the weather, or he can't gain anything by proving something about the weather. So it's the mathematician one. So the mathematician has the least potential for bias because he's the least involved personally. And it's not necessarily because he's a mathematician, but because the other two examples have clear potentials for bias. Next question. Which of the following is not a measure of central tendency? So what you need to know is there are 3 measures of central tendency. Okay, the one is the mean, the other one is the mode, and the other one is the median. So that's what we're looking for over here: mode, median, and outliers. So outliers are definitely not a measure of central tendency. Next question. What type of graph is represented here? Histogram, bar graph, broken line graph, scatter plot, or pie chart? Now it has to be a histogram because it's got bars, so it's not a line graph or a scatter plot or a pie chart. And the histogram differs from the bar graph in that the different bars are next to each other and touch each other. So it's a histogram since the bars touch one another. Since the bars touch. Okay, next question. So they give us temperatures in Pretoria for a 24-hour period. It's measured in degrees Celsius. And then calculate the mean of the above data set. So now you need to know that when the mean is calculated, you add everything together. 27, 28, 26. So you add everything. So you add everything together and you divide it by the amount of data points. 1, 2, 3, 4, 5, 6, 7, 8. Add everything together, divided by 8, and that gives you the mean. That gives you a total of 22.38. 22.38, just see here that they prefer that you use a full stop as the decimal separator. Next question, what is the median of the data set? So the question is, what's the median of the data set? First thing you always need to do when working with the median is to first order the data from smallest to largest. So we have 17, 18, 20, 20. Okay, so first thing you always need to do is to order the data from least to largest, and then the median is always in the middle. So the middle in this case would be this line over here, since there are 1, 2, 3 points to the left and 1, 2, 3 points to the right. But what's the median now? Now the rule we use, if there's an even number, which means we're not selecting a specific point, is you calculate the average of the 2 points in the middle. So it's 20 plus 23 over 2, and then that would be equal to 21,5. That's your median, 21,5. Okay, and then the next question, what is the mode of the data set? So the mode is always the value that we see the most. So the mode in this case is just 20. The mode is just 20 because 20 is the only one that occurs more than once. So the mode is just 20. Next they asked, calculate the range of the data. Now the range, you should know, is always the largest data point minus the smallest one. Easy, so it's just the max minus the min, and then that's equal to 28 minus 17, which is equal to 11. So the range is 11. Next question. Question 8 says that 17 is an outlier because it's the lowest value of the data. Now this is clearly false. This is clearly false because an outlier is something that's way bigger or way smaller than the rest. False because an outlier should be way larger or smaller than the rest. Outlier so this is definitely false because an outlier is a data point that's a lot bigger or smaller, and 17 isn't a lot bigger or smaller, it's just the smallest. Last question, what time of the day was 28 degrees probably measured? So if all the temperatures are measured in a 24-hour period, then we can probably say that the highest temperature was probably in the middle of the day. So it's usually in the middle of the day that we have the highest temperature. And then you'll see under the options that would be afternoon, right? And that's it for this section, and that's it for this section. Thanks for listening. Okay, then the last section is section G, probability, 9 marks, and just in bold use a full stop as the decimal separator. Okay, first question, which phrase best describes the probability below? So we have 6/7. And since 6/7 is quite a high probability, it means that it's likely. Something is likely to occur but not guaranteed. Okay, so it's very likely but not guaranteed or definite. And then question 2. Question 2. Consider the following 4-color square. If a tile is randomly chosen, fun competition, which tile is the least likely to be chosen? And you're looking for the smallest probability in one of the squares. So now you have 2/5, 5/8, 35%, and 0,7. So I guess it might be the easiest if you write everything as decimals. So 5 over 8 we have as, so 5 over 8 is 0, 0.625. 2 over 5 is 0, 0.4. Then we have 0, 0.7, and 35% is 0, 0.35. So 35% is the smallest probability. So that would be the square that's the least likely to be chosen, and this is the color brown. Next question. If a die is thrown, what is the probability of it landing on a 6? Give your answer as a percentage. So the probability of a die landing of a 6 is just 1 over 6, because there's only one way a die can land on a 6, and there are 6 options. And 1 over 6 as a percentage, 1 over 6 as a percentage is, you can just say 1 over 6 times 100. That's equal to 16.67%. And then they want us to fill in 16.67. Next question. If a die is thrown, what is the probability of the number being more than 3? Okay, so what you'd always do at the top of a fraction is how many ways are there of throwing a number on a die more than a 3? The options are 4, 5, and 6. So there are 3 options. How many options are there in total? 6, because the die has 6 faces. Therefore, the answer is 1 over 2. They ask for it as a decimal fraction, so the answer is 0, 0.5. Okay, next they give us a chessboard that consists of 64 squares, 32 of which are white and 32 which are black. If a piece is randomly put on a square, what is the probability that the square is white? Again, first we start with the fraction. How many possible ways are there that we get what we want, aka white? Well, 32. How many ways are there in total, or squares are there in total? 64. And then they ask for the answer as a percentage, so the answer is just 50%. Next, they give us a tree diagram, okay, of a random choice between red and blue applied 3 times. What is the probability of picking red exactly once? So what you do now is you go to all 8 options. So we have 1, 2, 3, 4, 5, 6, 7, 8 different end options of the 3 random choices. And you look for all of them where red occurs exactly once. So where there's only one R, so that's RBB. RBB is the one option. We have RBB, we have BRB, and then we have BBR. That's your only 3 options with exactly one red. Therefore, we have 3 ways of getting what we want. There are 8 different outcomes in total. They ask for our answer as a decimal fraction. So on your calculator, you just type 3 divided by 8. And if you have one of the Casios, then you just press the SD button to change it to a decimal fraction. To 2 decimal places, we have 0, 0.38. 0, 0.38. Okay, next they give us a 2-way table of a grade 10 group. Boys, girls in total, maths, lit in total. First question, if a learner is randomly chosen from grade 10, what is the probability that the girl was chosen? Okay, now, to answer this question, I have always the same method for probability. At the top, you write how many ways are there to get what we want. Okay, so we want a girl. So how many girls are there? We look for girls, and then the total number of girls is 28. So that would be 28. And then we look at what is the total number in chosen if a learner is randomly chosen from grade 10. So all the learners together are 43. So then the answer is 28 over 43. They ask us to give the answer as a decimal fraction. So then this is equal to, 0, 0.65. So there's a 65% chance of picking a girl randomly from the grade 10 group. Next question. If a boy is randomly chosen from grade 10, what is the probability that he has maths? Okay, now you need to focus. Right? So, first of all, how many ways are there to get what we want? We want a boy that has mathematics. A boy that has mathematics, there are only 9 of them. Okay? And now, what is the total number of options? It's not 43 because they specifically tell us if a boy is randomly chosen. So how many boys are there? 15. So check here what the answer is. Our answer is 9 over 15 because there are 9 boys that take mathematics and there are 15 boys in total. And they asked to give the answer as a percentage. So you can just take 9 over 15 and times it by 100. And then you get 60%. Then you get 60%. Again, they only want the numeric value. And then the last question. How many girls should change from maths to maths lit such that the amount of girls that has each subject is the same? So at the moment there are 18 girls that has mathematics and 10 girls that have mathematics literacy. So to get them the same, we want 4 people to change over, because if 4 change over, at the moment it's 18 versus 10, where if 4 change over, if 4 go over, we'll have 14 because 4 of them go, versus 10 plus 4 is also 14, so this is what we're looking for, 14v14, and then that's your answer. Your answer is then 4. So then our answer is 4, and that's the end. Thanks for listening.